Hi everyone, in this lecture video, we are going to talk about measurements in science. Okay, so before we get into that, I would like to actually remind you of a few things that we did cover in the last video. Okay, so the first thing is that you have the self-study reading assignment, chapter section 1.1. So don't forget to go to the OER textbook and read the this chapter and then fill out the exercise or answer exercise number 1 and 2. Okay, so the answer key for this will be posted on Moodle. Okay, so you are going to see that post on Moodle. And so here is where you can find the OER textbook. Okay, so under required course material, you can click on one of these two files. Okay, so one is for accessibility, it's content hyperlink. The page number might not be the same as what is listed on the table of content because it got shifted, but you have the link to click on to a certain topic. The second one, OER textbook in the PDF format. So this one is good for printing if you want to print out, or you can order it to be printed through the campus store as well. Okay, so as I mentioned in the course overview video already. Okay, so again, so OER textbook would look like this. And what you are going to do is you are going to look for chapter 1.1 to read the text and then answer the activities. Okay, so you're going to answer this question right here. The answer key for that will be posted on Moodle. So under chapter 1, DIY solution, so you can find the solution there. Okay, so for this one, right, so section 1.1, page 2 key. So therefore, you should be able to check your work according to what I have here. Okay, so I want you to actually do it first before you check your work with me to just evaluate your understanding. Okay, so the second reminder is that we went over chapter 1.2 and 1.3 in the previous video. So one of the exercise that I asked is to complete exercise 1 to 2 right after reading section 1.2. So you should be able to check your work against the answer key as well. So this one, do the same thing, right? Read OER textbook, fill out the lecture manual, and then check your work against my key. Okay, so the key is posted under DIY chapter 1 solution. Okay, so that one right there. All right. So last video, we talked about classification of matter and property of changes. The reason for that is because we're looking at into what is matter, right? So why do we study them, right? Because they undergo changes, right? So that they undergo chemical reaction. And the reason why we classify them because it's easier to study their property, because if they are put in the same group, they would have the same physical property, or if they undergo changes, they are going to behave similarly, right? So that's why we learn about classification. So these are the summary of what we covered last time. Okay, so we're looking at classification of matter by composition, by state of matter, and also by property and changes as well, or what we call physical and chemical changes, right, or properties. Okay, so this chapter, we are going to focus our attention on the measurement that come with when we are going to study those changes, right? So when you are studying those changes, you need to somehow design an experiment, right, in order to figure out what changed and what quantity that is changed, right? So the measurement that come with that, that's what we're going to talk about. Okay, so this one, the homework that related to this chapter is listed here. Okay, so you can read the OER textbook for this chapter as well. It's going to be under chapter 1.4. So it's look like this, right? You are going to see the learning objective, and then there will be the text that describe chapter 1.4. So pretty much my video is going to be the summary of OER textbook, right? So in like a video here. So as I mentioned before, when we talk about science, is pretty much the collective, right, systematic study of something, right? So when a person or a scientist, right, so curious or have a question, they are going to form hypothesis, which is an explanation, and it might not be true. That's why you have to prove it, right? It's a tentative explanation, right? So in order to prove this, you need to decide the experiment, and this experiment is going to come with the measurement, and also eventually it's going to lead to the conclusion as well. And if this experiment has been confirmed, right, then the theory or model can be developed, right? So pretty much what we are going to focus on in chapter 1.4 is going to be the measure part. Okay, so it's going to be the measurement part. So when looking at number like this, it doesn't mean anything because to you and to me might not mean the same, right? So for example, you might think that, oh, 21 is my age, right? Or 21, there are 21 chips, right? For example, right? Or 21 pens, for example. So it can be anything. So without a unit, the number doesn't mean anything. So therefore, in this chapter 1.4, we are going to focus both number and also unit as well. The expectation for this unit is that when we talk about number, you will need to be able to report these in terms of decimal form. And you also need to be able to report in terms of scientific notation as well. Okay, so there are two of them. So we're going to go over this. Decimal form would be, for example, if I have 0.010, so that would be decimal form. Okay, so scientific notation is when you actually move the decimal to be after the first non-zero digit, right? So it would be that, right? So 0. And then you are going to times it by the notation, right? So scientific notation, so that would be 10 to negative 2, for example. So we're going to learn about how to do this. Okay, so now the unit that you are going to take a look at would be the international standard unit. Okay, so or the SI unit, or this is similar to the metric unit. Another one you are going to see is going to be the English unit. Okay, so for example, mass, right? When you describe mass, you can either use the SI unit or metric in terms of like grams or kilograms, right? But when we talk about English unit, that can be described as pounds, for example, right? So we're gonna take a look at this. And eventually in chapter 1.5, you are going to learn how to convert between this, right? You are going to learn how to convert between these two units. And also the unit, the metric unit that also contain the prefix as well. Okay, so that's kind of like another layer that we're gonna add later. Okay, so but just note that again, so this chapter we are going to focus on number and unit. And in addition to this, for chapter 1.4, we are going to add the uncertainty of the measurement to it as well. Okay, because every measurement comes with the uncertain, so we need to report what is the error that comes with that. Okay, so pretty much you are going to learn these three portion of this chapter. Okay, so let's start with one. Let's start with the number. I would like you to go all the way to page 10 first. Okay, so we are going to revisit the previous page later. Okay, so this one we're gonna focus on the number. Okay, so as I mentioned before, the two forms that you will need to be able to report would be one is in scientific notation and the other one is in decimal form. So again, the difference between the scientific notation and decimal form would be the scientific notation would contain 10 to an exponent, right? So whatever that is, and the decimal form would be just the decimal. There's no notation. So in order to go back and forth between these two, what you will need to do is you are going to move the decimal point to the left or to the right in order to achieve what you want. Okay, so how do we do that? Okay, so let's take a look at example 2. Okay, so example 2, we are going to convert the given scientific notation to the decimal form. Okay, so that means in this case, we somehow need to move this decimal point right here. Okay, so how many times do you need to move is depend on the exponent, right? So in this case, it's positive exponent 4. So therefore, in this case, you are going to move the decimal point 4 times. Now you may ask me, hey, should I move to the left or should I move to the right? I want you to look at the value of the exponent. Okay, so if you get the positive exponent, you are going to end up with a big number. So therefore, you need to move your decimal point in such a way that it's going to provide you a big number. So in this case, I'm going to move this way. Okay, so if I move that way 4 times, this is the number that I get, which makes sense, right? Because this 10 to the 4th is the same as 10,000, right? So pretty much you multiply 10,000 to this, right? So you probably notice that this number right here will come out to be a big number, right? Because you actually multiply by 10,000, okay? So now when you deal with a negative exponent, right? So this is a negative exponent, you will need to know that your value would come out to be a small value, right? So that means in this case, you need to move this decimal place in such a way that it's making the number to be even smaller than this, right? So in this case, you are going to move it to this way, okay? So 3 times. So therefore, you are going to get 0.001358, right? So you probably notice that you move the decimal so that now the number becomes small, right? So smaller than is given here. Okay, so I want you to use the method that I just mentioned and go ahead, complete C, D, E, and F, and G. Okay, so you can pause the video now to complete those. And when you're ready, then resume your video again. All right, so now let's check your work together. So this is what I get right here. Okay, so If you answer some of this wrong or you still like really confused, please do not hesitate to reach out to me. Okay, so you need to be able to do this throughout the whole series of chemistry class. Okay, so just make sure that you know how to do this. Now let's take a look at number 3. Okay, so this one is giving you the decimal form, and you will need to report these numbers in form of decimal form. Okay, so I'm going to revisit appropriate prefix multiplier later. Okay, so this is going to be later. I'm going to revisit this later. Right now, we're just going to convert all this value into scientific form. Okay, so that's all I'm going to do. Okay, so in this case, I'm going to do the same thing here. We have the decimal place, right? For scientific notation, you need to move that so that it's going to be after the first non-zero digit. So that means in this case, I'm going to move all the way to here, right after that. So that means my report number would be 1.11 times 10. 10 to how many times that you move? I move 1, 2, 3. I move 3 times. But remember, this number right here is small, right? 0.001 is small, smaller than 1. So therefore, I need a negative exponent. So therefore, I'm going to use a negative exponent there. So therefore, in this case, these two values right here are identical. One report in scientific notation and the other report in decimal form. Okay, so now what about, so I'm going to let you do B and D yourself. Okay, so let's take a look at C. What about C? Here, you don't see the decimal point for this case, but because it's 30,000, so therefore it's implied that the decimal place would be right after that last zero. So you are going to move this to all the way to the first non-zero digit on your left. Okay, so you are going to move all the way to here. So 1, 2, 3, 4. You move it 4 times, so it's equal to 3.0800. Okay, so times 10. You move how many again? 1, 2, 3, 4. You move 4 times. It's going to be raised to the 4th. Well, this number is really big, right? It's bigger than 1, right? 30,000, that's a big number. So therefore, your exponent is going to come out to be a positive exponent. Okay, so it's going to come out to be like that. Okay, so therefore, in this case, these two values are identical. It's just report in a different form. Okay. Now, I would like you to pause the video to complete B and D. And when you're ready, resume the video again to check your answer. All right, now let's take your work together. So again, if you get the answer differently, please also contact me as well, so that way we can address your concern. Next, we are going to take a look at units of measurement. Okay, so when I talk about length, mass, time, temperature, amount, and volume, you will need to know what are the units that associate with those. Vice versa, when I give you the unit, you will need to be able to tell me as well, what would it describe, right? Does it describe length? Does it describe math or whatever, and so on? Okay, so 3 unit system that we are going to learn today would be: one is the International System of Unit, or the SI unit. This unit used most in science. Okay, so English unit would be the unit that we use here in the US, right? And then the metric unit would be the unit that pretty much the rest of the world use. First, let's take a look at length. Okay, so the SI unit and metric unit for length would be the same, which is meter. For English unit, it can be inches, it can be foot, it can be yard, right? So it can be any of those. Let's take a look at mass. Okay, so when I describe mass, right, so the unit that come with mass can either be kilograms or grams or pounds or ounce, right? So it depends on like what type of unit that you are going to use. And if we talk about time, right, so time for SI unit would be second, same as metric as well, and English can be second as well, and also like sometimes it can be after, for example, day, right, hours, minutes. So all of those describe time as well, like month, week, years, right? So those describe time. Temperature, Kelvin is used most in science. Okay, and then metric unit would be degrees Celsius, and also sometimes in some experiment you also measure them in degrees Celsius as well. You just need to later convert into Kelvin. And then English would be like Fahrenheit that we use here. Okay, so amount, so this one, you are not going to see this until you learn about chapter 2. Okay, so for science, okay, so the amount of or the quantity of an object we can describe, or like electron or molecule or whatever, we describe those in the number of mole. later we are going to define what is mole, right? So in English, an example of the amount or quantity would be like a dozen, right? So that would be described like amount, like a dozen eggs is equal to like 12 eggs, right? So we're gonna learn about this later. Volume is going to be cubic meter for the SI unit, liter for metric unit, and for the English unit can be like cup, quarts, or gallon, right? So that means in this case, my expectation here for you is that if I give you any of these units, you need to be able to tell me what it describes, right? Vice versa, if I give you like, for example, mass, you need to know what would be the unit that appropriate for mass. Okay, so the next thing we're gonna learn is going to be how to convert between these two, right? So for example, right, how do you convert from inch to meter, or how do you convert from like foot to kilometer, for example, right? So we're gonna learn about that within this chapter 1.4 and 1.5. Okay, so please note that the units that come with more than one, for example, cubic meter is contain 3 of the meter. So this one we call derived unit. We are going to talk about derived unit later as well. Okay, so for example, those that involve with area or density that contain more than 1 unit, those are going to be described as derived unit. Okay, so you're going to see this. So the next thing we are going to take a look at is going to be the prefix multiplier. Okay, so for example, if you are given this unit here, micrometer, millimeter, centimeter, kilometer, first you need to ask yourself, what is that described? Okay, so because it's in meter, they all have the same common meter, right? So they all of these contain the common meter. So therefore, in this case, this meter right here is going to be the base unit. And this base unit meter is going to describe length, right? Because we just saw that. Okay, so that means all of this is going to describe length, just a slightly in different unit. The before the word meter, those are what we call prefix. Okay, so you can add prefix, right? The name implied is come before, right? So prefix always going to come before the base unit. Okay, so for example, you might ask me, hey, when I see something like this, when I see something like mm like this, which one do I know? Which one is going to describe meter? Or note that always going to be after the prefix, right? So that means the one that come before, that would be the prefix. In this case, the prefix would be milli. We're going to talk about that in just a few minutes. What are the prefix list? Okay, so that means in this case, the prefix will tell you something, right? So what is that? Okay, so I'm going to go ahead, compare the value. So that way it's easier for us to see. If I compare kilometer to just a meter, okay, so the difference between these two, again, is just the kilo that's being added to the meter, right? So these two also describe the length. Okay, so if I do this, it turns out that there are 1,000 of a meter that is equal to 1 kilometer. So that means 1,000 of this is equal to 1 of this. So therefore, in this case, you see that 1 kilometer is actually bigger than 1 meter because the unit kilo, right? So kilo, whenever it's come before any base unit, is always going to be the bigger value than the meter. Now, if you compare 1 meter to 1 centimeter, it turned out that 1 centimeter is 100 times of a meter. Or another word is mean that in order to make centimeter to equal to meter, you need 100 of a centimeter to be equal to 1 meter, right? So that means in this case, you see that centimeter is actually smaller than a meter, right? So that means in this case, you will see that this unit right here is smaller. You can also compare this with other prefix that come with the same base unit, right? So in this case, for example, millimeter, right? So it's turned out that 1 millimeter is equal to 1,000 of a meter, right? So we see that it's a lot smaller than a meter, right? Or another word, you can see that you need 1,000 of a millimeter in order to be equal to 1 meter, right? So it's a lot smaller. So this one is even smaller. So that means in this case, milli, right, even smaller than centi. And centi is smaller than just the base unit, right? So that's what it's described. And I can just keep going on, right? So for example, if I want to look at micrometer, right? So it's turned out that 1 micrometer is a millionth of a meter, right? Or you can say that you need million of this micrometer to be equal to 1 meter, right? So it's a lot smaller. So that means in this case, micrometer is smaller, even smaller than the millimeter, and also smaller than centimeter as well. So that means the prefix will tell you about how large or small of a base unit is, right? So for example, kilo, anything that comes with kilo would be very big, right? So anything that comes with milli or centi or micro, right, would be small, right? So it's considered to be small unit. So these are the list of the prefixes and multiplier that you need to know. Okay, so pretty much anything that contain kilo would be the biggest unit for this class you're gonna learn. There are more bigger than this, but I'm not going to cover. Okay, so for example, like giga, right? So for example, when you heard about gigabyte, right? So that's just like times 10 to the 9th, right? So it's the billion of it, right? So in this case, we're just gonna keep top at 1,000, which is kilo. Okay, so deci, smaller than kilo but bigger than centi. Centi is smaller than deci but bigger than milli. Milli is smaller than centi but bigger than micro. Micro is smaller than milli but bigger than nano. And in this course, we are going to keep nano to be our smallest. Okay, so if you see, there might be other as well, right? For example, picometer, right? So when you talk about the size of an atom, like in picometer, so that is even smaller than nanometers. So, but I'm not gonna go over that. Okay, so at this point, we're just gonna keep it simple to for only this list. Okay, so what all this mean? Okay, so these prefix right here contains symbol, right? So these are the symbol that you need to use. This symbol go with the base unit, such as you can put this kilo with grams. You can put this kilo with let's say time, right? For example, hour, for example, right? So you can put this with anything. Okay, so same thing with nano as well. You can put nano with meter or nano with one of amount, right? Which is like mole, right? So nanomole, for example, it can be with any base unit. Okay, so again, how do you know which one is the base unit? The base unit have to come after, right? So these are come after the prefix. Okay, so these are the prefix. Okay, so these are the prefix. Okay. Note that. All right, so now what are each of these prefix mean, right? So kilo mean 1,000. Okay, deci mean 10th. Centi mean 100th. Milli mean 1,000. Okay, so this is 1,000. This is 1,000. Okay, so they're not the same. Micro mean millionth, and this one is mean billionth. Okay, so which if you want to write as the fractional form, kilo would be 1,000, right? And then the deci, okay, so I'm gonna list like this. Okay, so it's equal to 1/10, right? So that's what it means. Centi is 1/100. That's what it means, which is equal to 10 to negative 2, 10 to negative 1, as it listed on this table here. Milli is 1/1,000. Equal to 10 to negative 3, right? And then micro is 1/million. So I'm going to shorten this in scientific form, okay, which is equal to 10 to negative 6, right? So, and then nano is 1/10 to 9 or 10 to negative 9, right? So these two are the same. Okay, so that's 10. Let me write that clearer. Okay, so that's what it means. Okay, so again, whenever that you use each of these prefix to put it in the base unit, it will tell you about how big or how small each of those are. Okay, so in this case, you will notice that if I put this, let's say in grams, right? So kilo means 1,000. So that means in order to make this 1,000 to be equal to grams, all you have to do is replace that kilo with the 1,000, right? Because kilo mean that, right? So you just replace it. So same thing here, right? So deci mean 10th, right? So therefore you are going to put 0.1 of a gram in there in front of that, right? So you replace D with that, right? Because that's the meaning of it, and so on. Okay, so for example, if you have like, let's say 2 nanograms, in order to make this equal to grams, because nano mean 10 to negative 9, so I'm going to write 10 to negative 9 here, and I'm going to use multiply by 2, right? So these two are the same. Right, so I just replace that, right? So that's one way to convert the prefix. Okay, so another way to convert this is by memorizing this list right here, right? So 10 decigram is equal to 1 gram, right? Because you need 10 of them equal to 1. You need 10 of the smaller unit to be equal to the big unit, right? So you need 100 of the centigram smaller unit to be equal to 1 bigger unit, right? So you need 1,000 of the smaller unit, right? Equal to 1 of bigger unit. You can do either way. You can use either one. It's going to give you the same result. Whichever one that is most comfortable to you, stick with that one. Okay, so I can encourage you to stick with just that one. Okay, so let's take a look at now the conversion. Okay, so as I mentioned before, you need to be able to convert back and forth between the two, right? So base unit and also the prefix as well. So let's take a look at kilometer. Okay, so again, because it's want you to convert to just a meter, so therefore in this case, you need to look up what is the definition of this, right? So kilo means 1,000, so therefore in this case, you are going to just add 1,000 into this, right? In order to check this, right, you probably notice that this is smaller unit and kilometer is a bigger unit. So therefore the value here need to come out to be a bigger value, right? So makes sense, right? Because it's bigger, 1,000 is bigger than 1, right? So you compare with that, right? So that means in this case, you are going to see that this 1,000 right here is bigger than this one. Okay, because for a big unit, you just you need a small value. But for a small unit, you need a bigger value in order to make them equal. Okay, so that's what it means here. So now I'm going to do vice versa. I'm going to do the opposite now. Okay, so if I do the opposite, you will notice that the one that's given here, meter versus kilometer, you will see that the kilometer is bigger than meter. So therefore, the number that go in front of this have to come out to be smaller than this number, right? Because you need a tiny amount of a big unit in order to be equal to the big amount of the smaller unit, right? So in this case, it needs to be smaller value. So therefore, in this case, how do I know it's going to be, what would be smaller value than 1? Well, it's going to be in a decimal form, or it's going to be in a negative exponent form, right, of the scientific notation. This one would be the same as 0.001. Okay. And this one, 10 to the third, is equal to 1,000, right? So that's what it means. Okay, so 1,000 meter equal to 1 kilometer, or 0.001 kilometer equal to 1 meter. Either way, okay, so we use the same concept. They are the same. Okay, so they describe the same conversion. All right, let's take a look at the next example. Okay, so in this case, we are going to compare between centimeter and meter. So we know that centi is smaller than a meter, right? So centimeter is smaller than a meter. So therefore, in this case, the number that go with a meter have to be smaller than 1. Okay, so in order to make that smaller than 1, centi is 100. So therefore, you are going to add 10 to negative 2 or 100 of this by 0.01 of a meter equal to 1 centimeter. Vice versa, right? So when I looking at meter, which is a bigger unit, bigger than centi, right? So this is smaller unit. The number that go with the centimeter have to be a bigger than number 1 here. So therefore, in this case, is going to be 100, right? So or 10 to positive 2. Okay, so it's going to be 10 to positive 2 in this case. Or this one is going to be 100, right? So 10 to positive 2 would be 100. Okay. All right, I'm going to let you go ahead, complete the rest of this. Okay, so resume the video again when you finish. Okay, so let's pause it now. All right, let's check your work together. So here are the answers. Okay, so if you get any of these incorrectly, please do not hesitate to reach out to me. Okay, so so that way we can address your misconception or concern or question right away. All right, let's take a look at the next example. So we did this example before when we talk about the conversion between scientific notation and decimal form, right? So the next thing is I'm going to add the prefix multiplier to report this measurement. Okay, so if you're looking at this, okay, so I'm going to start with A first. Okay, so if you start with A, you probably notice that the scientific notation that we have here, right, is 10 to negative 3. If you know what would be the scientific notation, then you can actually look at the table that we see, right? So if you go back here, 10 to negative 3, that is describe milli, right? So 10 to negative 3. So therefore, in this case, I'm going to go back here. This one right here is going to equal to milli. Therefore, if I want to report this number or this measurement in form of prefix multiplier, I can do that, right? So it's going to be, the number will stay the same, 1.11. And because 10 to negative 3 is equal to milli, therefore this one is going to be milli followed by second, right? So prefix come before base units, right? So this is going to describe your prefix, right? So this is going to describe your prefix that would come before your base unit. Now I want you to go ahead, look up the number or the prefix multiplier again. Okay, so on page 9, and tell me what is negative 6. Okay, so if you're looking at this, oh, negative 10 to negative 6 is micro. So therefore, in this case, so I'm going to change the number. This is micro, so it's going to be reported as 7. And then 10 to negative 6 is micro, so it would be micrometer. So that's it, right? So you omit that now because that's already replaced by micro, the Greek letter. Now, what about 10 to 4? Okay, so if you go all the way to the next page, so the page 9 here, you don't see any 10 to positive 4, right? So it is maxed out at 10 to positive 3 that we have on this list. So therefore, in this case, what you are going to do is that you need to adjust this scientific notation a little bit. So that way you can actually report with the appropriate prefix. Okay, so because 10 to positive 4 is not exist, so therefore I'm going to make this notation to be the same as what is listed in the prefix multiplier list. So in this case, I'm going to move the decimal one more here. So I'm going to report as 30.800. So that way my notation would be 10 to the third, right? So meter. So now 10 to the third is actually equal to kilo. So therefore, your final answer with the appropriate prefix multiplier would be 30.800 kilometer, right? So that's what it means. Note that when you check your answer, it have to be the same, right? So these two, because we are looking at, so these two right here, right? So this number have to be the same as this number, right? So this is a big unit. This is a smaller unit, right? So therefore, you probably notice that the number that comes with the smaller unit is actually bigger than the number that comes with the big unit. These two need to be identical. Okay, so they are identical, they just report in a different unit. Same thing here, 7 micrometer is identical to 0.00007 meter, right? So they are identical. So you probably notice that meter is a bigger unit than micrometer. So therefore, the number that come with the meter is actually smaller than the number that come with the micrometer. But these two are going to be the identical value. Okay, so they describe identical value just in a different unit. Okay, so now what about D? Okay, so same thing here. If you look up 10 to negative 2, this is centi, right? So therefore, in this case, your answer here would be in centi. Okay, so it would be 2.24 centimeter. You might ask me, hey, Ami, is it possible for me to report this number in form of 22.4 times 10 to negative 3? Because we know that we have prefix for 10 to negative 3. The answer is yeah, you can do that, right? So in this case, the answer would be what? 22.4. 10 to the negative 3 is milli, right? So it would be millimeter, right? So it can be that. So that means there these two are, I accept both, right? So I accept this is correct to me. This is also correct to me because these two values describe the same value here, but just different unit. Okay. All right. If you have this question, please do not hesitate to reach out to me. Okay. So I know that going back and forth and add the prefix multiplier to it sometimes can be very confusing. Okay. So just make sure that you reach out to me if you have any questions. All right. The last unit that we are going to take a look at is going to be the derived unit. Okay. So the derived unit is going to be the combination of other units or of the same unit several times, right? So for example, area, right? So area is going to be the measurement of the two dimension between length and width, right? So in this case, you are going to pretty much get the unit of length multiplied by each other 2 times, right? So is going to come out to be a square. Okay, so this square of a meter is going to be the derived unit that describe area. Okay, so if you see anything cube, that is going to be the one that describe volume, right? Because you pretty much multiply the unit of length 3 times, right? So therefore you are going to get the, for example, cubic meter. Okay. And then another one that I want you to know is the density. Okay, so the density is going to be the derived unit as well because it's combined between mass and volume. Okay, so so this density right here is going to equal to mass over volume. So we learned about the unit of mass before. It can be like grams, kilograms, pounds, right? So it can be any of those. And when you see those per the unit of volume, such as cubic meter, cubic centimeter, liter, any of those volume units, right? You need to know that that is going to describe density, right? So for example, in this case would be grams per cubic meter, or grams per cubic centimeter, or grams per milliliter, right? So any of those. So the grams per cubic centimeter and grams per milliliter would be the 2 units used most often in our course. All right, so let's take a look at the density real quick. The density is quite important because actually can tell you about the identity of the substance as well, because each substance would have different density. Okay, so density also temperature dependent as well, such as if you talk about the same substance, for example, water, right? So water at 0 degrees Celsius versus water at 25 degrees Celsius or at 4 degrees Celsius, they are not the same, right? So in this case, you will see that they are not the same. Okay, so if you have an unknown substance and you don't know what it is, right, you can also use density to help you determine the identity of the substance as well. Okay, so we're gonna see the example later on. Okay. All right, so let's take a look at the conceptual understanding of the density real quick. So if you have 2 objects, right, so A and B, they both have different volume, but they both has very similar mass. Which one you think has a greater density? The answer would be A, right? Because A has a similar mass to B, but A packed together in a smaller volume, right? So it's denser, right? Now, what about if you have a solid object? Okay, so I'm talking about solid. Okay, I'm not talking about any other states of matter. Okay, so if you have a solid A, cube A, for example, you have cube A. If I cut that A in half, okay, so I'm gonna cut that in half, chop it in half. So that means the volume of A decreased, right? Because you cut out that part of A, so the volume of A decreased. So do you think that this is going to affect the density of A or not if the temperature stay the same? So the answer would be what? Well, let's take a look at this, right? So because you cut the volume in half, so therefore you also cut the mass in half as well, right? Because you take away that part. So therefore the density would stay the same. Please note that again, this one is going to apply if the temperature stay the same, okay? Because temperature will affect the density of the substance. So next, we are going to take a look at how we can determine density by giving length, right? So in this case, we are given the unknown metal cube. Okay, so we are given grams and length, and we need to find out what is the density, and also eventually we will need to use this density to compare the known value to find out which one would be the identity of that unknown metal, right? So in this case, you are going to pretty much use the given mass in grams, right? Because grams describe mass divided by volume, but we don't know volume because 1.1 centimeter describes just length. So volume is length times width times height. So therefore, in this case, you will need to know those first. But the keyword of this problem is what? Cube, right? So that means cube mean all those length, width, and height would be the same, right? So they need to be identical. So therefore, with given length, you should be able to find out the volume. Okay, so the volume would be when you multiply all those 3 together, right? So you are going to get it in cubic centimeter. Now put this together, you have mass already divided by the volume. You are going to get the density of 19.3 grams per cubic centimeter. Therefore, the identity of this unknown would be, it would be gold. Okay, so that means in this case, our identity of this unknown metal would be gold. Note that this density method of identification of matter would only work if that metal is a pure metal. If you have a metal mixed with some other metals, which is what we call alloys, this might not work, okay, because alloy is dependent on the composition of each metals that mix together as well. Okay, so it's only work with the pure substance, not the mixture. Okay. All right, the second method of finding density is going to be when you use water displacement. Okay, so this one can be used when you have an object that you don't know the exact volume, right? So it's come in a form that we can't measure the volume like easily by like measuring length, right? So for example, if you have a ring, right? So it's and you want to know what is the density of a ring, right? So of a gold ring. And how do we know the volume, right? So in order to find out the volume of a gold ring, you can also use the water displacement as well. Or if you want to know the density of a rock, right, you can also put rock into water and let it displace water, right, to obtain the volume of the rock as well. So that would be an example of object that we can use water displacement to find volume. Okay, so let's take a look at example 4. Okay, so in this case, a student purchased a ring, right? It's assuming it's gold, but it's not sure, right? So in order to identify whether this ring is pure gold or not, we are going to figure out the density of this ring that we purchased, right? So in this case, we figured out that the ring, the mass come out to be 10.2 grams, right? And then the volume, okay, what is the volume here? It said that the initial volume of water before adding the ring is 25.6 milliliter. And after you put the ring in, the water, after you add the ring, the volume of water now has become 37.5. Okay, so what it means is that if you have water, right? So this is water. It started at 25.6 milliliter, right? Now you add an object in. What would happen if you add an object in? Well, water is going to rise, right? So water is going to rise. So similar to when you are soaking yourself in a hot tub, right? So you will see that the hot tub, the volume of water of the hot tub will rise, right? So it's similar to that. So what does it mean then? Well, it means that this difference right here is going to be the volume of an object, right? So it's going to be the volume of this, right? So that's what it means. Okay, so in this case, what you are going to do here is going to be pretty much find out, right? So you are going to find out the difference, right? So after you get the difference, which is the volume here, you are going to use given mass divided by volume. You are going to get the density. And it's turned out that when you compare this density of a ring to the literature value, they are not the same. So therefore, the conclusion of this is that this student did not purchase a pure gold ring, right? It's something else. It might be an alloy, or it might be other metals that they sell you. So it's not a gold ring.